Hello everyone, welcome to our channel. In this video we will talk about pointer and we will give one example of pointer. Most of the students find that this concept is a bit complex, but in this video we will give one example we demonstrate pointer with an example, and it will be much more easier for you. So without wasting time, let's start. Before starting a program, we want to give a definition of pointer. So a pointer is a user-defined data type which creates special types of variable which can hold the address of primitive data type like character, integer, float, double, or user-defined data type like function, pointer, etc. Or it can hold the address of the derived data type also. For example, array, structure, union, enum, etc. There can be a multiple type of pointer: null pointer, dangling pointer, generic pointer, while pointer, complex pointer, near pointer, far pointer, etc. Also, based on the data type, the type of pointer can change. For example, if we apply pointer to an integer, this will be a pointer to an integer. If it will apply to a double, then it will be a pointer to a double. If it will apply float data type, it will be pointed to float. Likewise, all the primitive data type we have. So still now, if you are not getting anything, you will be able to understand the concept with the example. So let's start with the example. So in our ID, you can see we have a program, and here in this line, we declared integer asterisk symbol then PC. It means this is a pointer to an integer. Pointer to integer. And here we declared a C variable, a integer variable. The name of the variable is C. Here we are initializing the value of C variable with 22. It means we have a variable C, and inside this C variable we are initializing value 22. And whenever we are initializing this variable, computer will create a address in memory location or a RAM. In our computer system, the address will be look like this. So for each and every variable we have a address. It can be different type. It is integer type, it will have a address. If we have a floating point variable or a double variable, each and every variable will be stored inside a address in the computer memory. So in this line, if we will print the percentile C, then it will print the address of the C variable. That means if we will print ampersand C like this, so it will print the address of C, and whenever we will give only comma and C without any ampersand symbol, it will print the value of the C. So only C will give the variable value, and ampersand of C will give the address of the variable. So in this three statement, we are initializing PC equal to ampersand C. That means PC is a pointer variable and ampersand C is the address of C variable. So address of C will go to this variable. That means if you will do that and we have a PC variable, then this address will store in this variable. And now if we will print the PC, that means the value inside the PC variable, it will be the address of C variable. That means inside this PC variable we have this value, so it will print. So if we will print the PC, it will give the address. And in this statement, if we will print the asterisk of PC, it means the value inside this address. That means if we'll print the asterisk of PC, it will give the value inside this address. That means it will go to this address and it will find the value inside this address. So asterisk PC will give the value 22. Now in this three statement, if we will initialize the value of C equal to 11, that means the value of variable C, it was previously 22. Now it will erase this one and it will store 11 inside the C variable. So this value will change, and here the value of a C variable will be 11. Now if we'll print the value of PC, it means the variable value of PC, and it will still contain containing the address of the C variable. That means this value. And again, if we will print the asterisk of PC, that means this time this asterisk PC will give the value as a 11, because this asterisk PC will go to this address. That means this address, and inside this address it will find the value of that variable. So this time this variable is containing 11, so asterisk PC now print 11. And in this two statement and in this three statement, now we are changing from the pointer, and we are giving the value of pointer of PC equal to 2, and then we are printing ampersand C and ampersand, not without ampersand C. So this statement will change the value of the C variable, and it will be 2, and it will change from 11 to 2. And if you will print the ampersand C, it will print the address of a C variable. That means again this time also it will print the same address. That means this one. And whenever we will print the value of C, it will print 2, because using this statement we changed the value of C variable from 11 to 2. Hope this example clears your concept of pointer. So if you want to see the real output using compiler from the IDE, so let's build and compile the program and see the output of the program. So here is our output of our program. You can see ampersand C will give the address of C variable, and whenever we are printing without ampersand C, it will give the value of the C. And using this statement we are initializing the value of PC variable with the address of C variable. And if you'll print the address of the pointer here with only PC statement, or with the name of the PC variable, which is actually a pointer variable, this will give the address of C variable. And again, if you will print with asterisk marks, it will print the value inside the PC variable's address. That means it is a dereferencing pointer, dereferencing pointer, and so it will give the value of the C variable, whatever the value containing the C variable. So whenever we are again changing the value C to C equals to 11, that means we are changing the variable value C to 11. So here same address will print with PC, and whenever we are giving the asterisk PC, it will give the value of that C variable, that means 11. And whenever we are giving asterisk PC equal to 2, that means we are indirectly changing the value of the variable C with 2, because this is a dereferencing pointer. We are changing the value with a address. And if we'll print now the address of C, it will give the same address. And if now we will print the value of C, it will give 2. So I hope this is clear for you. If you have any confusion, you can watch the video again, and if you have a question, you can put it in the comment section. We'll try to give the answer as soon as possible. Thank you very much for watching this video. Bye bye.